Hi dear students, welcome back to your chemistry class. Today we are going to continue with the previous lesson, which was about the chemical reactions. So we have studied two types of them, and today we are going to study the third one, which is called combustion reaction. So what does the word combustion itself means? It means burning. When we burn something, it means combustion. So in combustion reaction, we burn something. Or the definition is a reaction of substance with oxygen in order to produce energy as heat or light. Some substances react with oxygen. You know that oxygen is an essential element that we need to burn something. So most of the time when there is no oxygen, nothing will burn. So oxygen is important, and we produce energy as heat or in form of light, but we produce energy. So oxygen is one of the important parts of this kind of reaction, and energy, producing energy, is also an important part. Also, in organic compounds, when the combustion reaction happens, totally in organic compounds, the product is carbon dioxide, water, and energy. This is the result of the combustion reaction in organic compounds. Generally, we represent it like this: organic compound plus oxygen, the result will become carbon dioxide, water, and energy. So the number of oxygen that we need and the number of carbon dioxide and water that they produce and the amount of energy, it is totally related to the organic compounds that we burn. So it can be any number according to the organic compound. So here is an example, about two examples here. The first one is CH4, methane, which reacts with oxygen. We need two oxygens here, two molecules of oxygen, and it will produce one molecule of carbon dioxide and two molecules of water and an amount of energy. Also here, another compound, organic compound, 5 oxygens, carbon dioxide, water, and energy. So if you look at these reactions, we have carbon dioxide, water, and energy, and oxygen here. The only thing that changes is the organic compound. So we can also define this combustion reaction for organic compounds like this. It is burning of organic compounds in existence of oxygen to produce carbon dioxide, water, and energy. That was all. Let's go to the next reaction. So here we are with the fourth type of chemical reactions. What is that? It is a single replacement reaction. So what is the definition? One element, the more active one, that start out by itself. At first it is alone itself, replaces another element. Which element? The less active one, the one which is less active than the first one in a compound, and kicking it out, and it kick it out of the compound. So we have an element in a compound. One of the element come and replace the other element which is less active in the compound. So here is some points. The positive replaces the positive, and the negative replaces the negative. What does it mean? Mostly we have ionic compounds, and the positive active element replaces actually the positive one. It cannot replace the negative one, because we need a positive and a negative element to make a compound. So the positive can replace the positive one, and the negative elements can replace the negative ones. Here is a series for nonmetals series of activity. In here, it is for the 7th group of table. Fullerene is much active than chlorine. What does it mean? It means that fullerene can replace chlorine in a compound, and much active than bromine and iodine. Chlorine is less active than fullerene. It means that chlorine cannot replace fullerene in any compound, but it can replace bromine and iodine. The same for bromine. It cannot replace these two, and it can replace the iodine, and the last one cannot replace any of these three elements. So here we are with the general representation. How do we show these kind of reactions? There is one element stand alone at first, and there is a compound. This element replaces one of the elements from the compound and take its place and kick it out of the compound. Like this, the blue one, the blue element replaces the green, and the green is out of the compound. Now here we have a compound of blue and pink. So, in real examples, iron, which is 0 at first, replaces the copper, and here we have copper is out of the compound and iron reacts with chlorine. Potassium with chlorine, potassium chloride, and react with fullerene because fullerene is more active. That's why it can replace the chlorine, and then we have potassium fluoride and chlorine is out of the compound. But here, so important, fullerene, potassium and fullerene, they are reacted with each other. Chlorine will take a negative charge, so it can only replace the negative elements in the compound. And the negative element in compound is actually fullerene. So fullerene, here we study, fullerene is much active. Chlorine cannot replace the fullerene. So that's why the result is no reaction. So that was all about single replacement reactions. Let's go to the double replacement reactions now. And finally, with the last type of chemical reactions. What is it? That is double replacement reaction. So before that, we have an important note here. Guys, if metals react with non-metals, mostly we have ionic compounds. Like here, sodium react with chlorine, sodium chloride, the positive and the negative. So what is the point? We write in the compounds, we write the positive first and the negative then. So we write the positive ion first and the negative ion then. And when two nonmetals, nonmetal with nonmetals, they react, they make different kind of covalent bonds, covalent compounds like hydrogen with oxygen, they make water. So what is the point here? This is so important. We write the positive first and the negative after the positive in the compounds. So let's go to the definition of double replacement reactions. In double replacement reaction, the positive and negative ions in two compounds switch their places. What they do is only they switch their positions. Here is a general representation that how they are. There is a compound like AB and there is a compound like CD. So what happened in double replacement reaction is that, A and C, both of them are the positive ions, and B, D are the negative ones. So these two or these two switch their places. If you see, we have the A here, A with B, but here A is with D. Here we have C with D, but here we have C with B. It means that B switch its place with D, or A switch the place with B. Here with the colors we can define them more easily. The blue and yellow, they are compound, and the green with the pink. What happened in double replacement reaction is that the blue changed the place with the green, or we can say the yellow changed the place with the pink. What happened here? Blue is with pink, these two, and green is with yellow. And a real example of this is magnesium oxide is a compound will react with calcium sulfide. Then magnesium and calcium are on their own place. Just the negative one, the negative ions change their positions. Oxygen with sulfur. So as I told before, positive first, then there is a negative element. Positive is first and then the negative element. So that was all about the chemical reactions. And if you have any question, comment down below, and for more videos subscribe to our channel. Thank you, goodbye, have a nice day.